Alrighty, in this video we're going to start Chapter 2, and no better place to start than Chapter 2, Section 1. And in here we're going to cover linear equations in two variables. And what we're going to cover in this section is, one, we're going to use slope to graph linear equations. We will find the slope of a line given 2 points on that line. We will write linear equations in two variables. Use slope to identify lines that are parallel and perpendicular, and use slope and linear equations to model and solve real-life problems. A lot of this is just going to be an Algebra 1 and Algebra 2 review. Parallel and perpendicular lines, I know for sure you did that in geometry last year. All this other stuff you should have started in Algebra 1 and saw again in Algebra 2. So, slope. The simplest mathematical model for relating two variables is the linear equation in two variables. Y equals mx plus b. The equation is called linear because the graph is a line. And remember the dead giveaway, look at the exponent of your x variable. That is x to the first power. That tells us for sure it will be a line. So here in the blue box we have our slope-intercept form of a line. The graph of the equation y equals mx plus b is a line whose slope is m and whose y-intercept is 0, b. Whatever this number is, positive or negative, will be where we cross the y-axis. So the slope of a non-vertical line is the number of units the line rises or falls vertically for each unit of horizontal change from left to right, as shown in the two figures below. So here in the left, we have our y-intercept 0, b is right here. And we're going to get to this some other point on the line. So we count the rise, how high up we go, and the run, how far we go left to right. And we would make that into a fraction. Maybe we're going downhill. And here we're starting at 0, b again, and let's say this is some other point on the line. So now our rise is not positive. We're not going up and over to get to the next point. We're going down and over. So here our rise will be a negative number, and then our run will be positive. So positive slope, you're going uphill left to right. Negative slope, downhill left to right. Here we're going to graph these three lines on this equation. I think in your notes, in the notes you have 3 different graphs for these. So we'll do one at a time and I'll erase them. The very first one, y equals 2x plus 1. Our y-intercept is positive 1, so we put a dot on the y-axis at 1. From there, our slope is the number in front of the x, and here it's a 2. And remember, we can put a 1 under any number without changing it. So our rise is 2, and then we run 1. Up 2 over 1, up 2 over 1, up 2 over 1. We can do that all the way off the graph. We could go from here down 2, back 1, down 2, back 1. Because this slope 2 over 1 is the same thing as negative 2 over negative 1. We can go down 2 and left 1. And then, of course, once we get a few points graphed, we can connect them with an arrow or a straight line. There we go. And here's a nice little check at the end. I've had students over the years, they'll graph it backwards. If you look at this, that slope there is a positive 2. If the slope is positive, you should be going uphill left to right. Real common mistake to graph it wrong, and then you could catch that with a quick check of your slope at the very end. So, now the next one here, looks a little confusing. If first we had y equals 2x plus 1, now we just have y equals 2. So is there an x variable in there at all? No, there's not. But we could put one in there, and it would look like y equals 0x plus 2. See, there's our plus 2. I just squeezed a 0x in there. And we can write 0 as 0 over 1. Just like we did the 2 in the previous example. So let's see what this line looks like. Y-intercept is 2, so 2 on the y-axis. Here we go up 0 over 1. Rise 0, run 1. Up 0 over 1. Up 0 over 1, over 1, over 1. There's our line. A horizontal line that crosses the y-intercept at 2. Okay, the third one, it's not ready to graph right away. X plus y equals 2. We want to put it in slope-intercept form. So I'm going to subtract x from each side. Y equals negative x plus 2. And remember, there is an implied 1 there in front of that x, so we could write it as negative 1 over 1 x plus 2. So the y-intercept again is positive 2. And now our slope is negative rise over run. So down 1, run 1. Down 1 over 1, down 1 over 1, down and over, down and over. And we're just going, kitty corner throughout the graph paper grids. So we would connect those into a line, and it would look something like this. Again, a little spot check at the end. We know that our problem had negative slope. The line better be going downhill, left to right. So, and here's how we would find the slope if we're not handed the slope on a silver platter. Remember, the slope is the change in y over the change in x, or the rise over the run. So if we have 2 points, we can find the change in y and the change in x. The slope, m, they use letter m for slope, of a non-vertical line through these points, x1, y1, and x2, y2, is m equals, the slope equals, change in y, subtract the y coordinates, over the change in x, subtract the x coordinates. And notice, the order isn't too important as long as we're consistent. We could also do this as y1 minus y2 over x1 minus x2. Notice the y, or x2 and y2 are right above and below each other. Same thing here for x1, y1. And that's the same, here I've written it reversed. Now the y1 and x1 are first, minus the other point, x2, y2. As long as you're consistent, you'll get the right answer every time. And remember, these x values cannot be equal. If x1 and x2 are the same, we would subtract the number from itself, and we would get a divide by 0. Remember, we don't like to divide by 0. So example 2, find the slope of the line passing through the points. Find the slope of the line passing through each pair of these points. And I'm just going to come up here and write our equation. M for slope equals y2 minus y1 over x2 minus x1. So for part A, our numerator r, subtract the x or the y values. So here let's subtract left to right. 0 minus 1 is our numerator. Negative 2 minus 3 is our denominator. Negative 2 minus 3. 0 minus 1 is negative 1. Negative 2 minus 3 is negative 2 plus negative 3, which is a negative 5. And then these negative signs will cancel, and we'll get a positive 1/5. Now, if you subtracted in the other direction, instead of having 0 minus 1, you would have had a 1 minus 0. And then you'd have a 3 minus negative 2. If we subtract that way, 1 minus 0 is 1. 3 minus negative 2 is 5. So we get the same answer either way, as long as you are consistent with the order that you do it in. Letter B. B. Subtract the y's in the numerator. 2 minus 2 over 2 minus negative 1. 2 minus negative 1. So 2 minus 2 is 0. 2 minus a negative 1 is 2 plus 1, or 3. And 0 divided by anything is 0. So that slope is 0, or it would be a horizontal line. Letter C. Numerator, subtract the y's. 4 minus negative 1 divided by 0 minus 1. 0 minus 1. Here we add the opposite. So our numerator is a 5. Denominator is negative 1. And you could leave it like that. Slope is good as a fraction, so we can recognize the rise and the run. But if you do write it as negative 5, there's no harm in that. I would accept that answer on a test or a quiz. Oops. Last one, letter D. D. So numerator, subtract the y's. 1 minus 4. 1 minus 4. Denominator, 3 minus 3. 3 minus 3. So 1 minus 4 is negative 3. 3 minus 3 is 0. Remember, when it was 0 divided by some number, that was equal to 0, and it was a horizontal line. Here, if we think about rise and run, if I give you any point to start with, you rise negative 3, you run 0. So we'd go down negative 3, put another dot, run 0. Run a negative, or rise a negative 3 down and run 0. So if we are dividing by 0, then we get undefined slope. The line is a vertical line. If you divide by 0, that's a vertical line. Undefined slope. 0 slope means you are horizontal. You're all run and no rise. Writing a linear equation in two variables. The equation of a line with slope m that passes through point x1, y1 is equal to this. So if we are given a slope m and we're given one point x1, y1, we just plug this x1 number in here, we plug this y1 number in here, and we put it in slope-intercept form. We'll just solve for this y. So we have a final equation, y equals something. And let's take it for a test drive. Find the slope-intercept form of the equation of a line that has slope 3 and passes through this point. So they gave us the slope, m. m is equal to 3, and our point here, x comma y, is 1 comma negative 2. So this x and y stay as variables. So we're going to have y minus, our y value here is negative 2. Y minus negative 2 equals, slope is m, that's a 3. And then in the parentheses, x minus our x value here, 1. So on the left, we will add the opposite. This will become a y plus 2 equals, distribute to 3. 3x minus 3. And to put it in slope-intercept form, we just want to get this plus 2 out of there. We will subtract 2 from each side. Y equals 3x minus 5. There's our equation in slope-intercept form. If I remember correctly, that's the last example. Here are some practice problems to try on your own. Find the slope and the y-intercept of this line if possible. You know, here we're in slope-intercept form. You can pick them right out of there. Here you're going to have to put this into slope-intercept form, and then you can pull out the slope and the intercept. 32, you're given 2 points. Find the slope, m. In the last one, you are writing the equation of the line in slope-intercept form. That's just like the last example we did. So pause the video, try the problems, and see how your answers check out. Okay, let's check our work here. Let me get a little more room. So for the first one, find the slope. The slope is in front of the x when you're in slope-intercept form. So here our m, our slope, is negative 3/2. The y-intercept is this number at the end, sign included. So here it's a plus 6. Our y-intercept is positive 6. It was in slope-intercept form, so we just pulled out the answers that we're looking for. Number 24, we're not in slope-intercept form. So the first thing we got to do is put this in slope-intercept form. I'm going to keep my 3y on the left. I'm going to subtract out this 2x. So now over here there is a minus 2x, and that's there's still a plus 9 on that side of the equals. Now we're going to divide everything by 3. By 3, by 3. So these cancel. We have y equals negative 2/3 x plus 9 divided by 3 is 3. So now it's just like the first problem. Here is our slope. It's right in front of the x. Our slope m is negative 2/3. Our y-intercept is this lonely number at the end, positive 3. Y-intercept 3. Number 32. We are given 2 points. We want the slope between them. So our slope, remember, that is y minus y over x minus x. So here are y values. Let's subtract left to right. 4 minus negative 4 divided by 2 minus 4. So up here we will add the opposite. 4 plus 4 is equal to 8. 2 minus 4 is negative 2. And we can either reduce that fraction down to a minus 4 over 1 or just a minus 4. That's our slope. Negative slope, it will be going downhill if we graphed that line. The last one is find the slope-intercept form given these two things. So that is y minus y sub 1 equals m times quantity x minus x sub 1. Plug in our numbers. Y minus this negative 5. That's equal to m 3/4 times x minus this negative 2. So on both of these, the minus the negative will turn into a plus. And on the left, we'll have y plus 5. And that's equal to, distribute here, 3/4 x plus, here's 3/4 times 2 over 1. So 2 over 1 times 3 over 4 is 6/4. And we could reduce by factoring out a 2 down to 3/2. So that's plus 3/2. Last little piece, we want to get y alone on the left, so we're going to have to subtract out a 5. So it's going to be y equals, we'll keep our 3/4 x plus 3/2, and now we're going to subtract 5 over 1, or rewriting that with the common denominator 2, multiply the numerator and denominator by 2, 10/2. So y equals 3/4 x. 3/2 minus 10/2 is minus 7/2. And there's our equation in slope-intercept form. Ooh, and we do have one more, next one over here, Team Mastery. Try this one on your own. Same type of problem. Put it in slope-intercept form, so it's the same thing as what we just did. Y minus this y coordinate 2 is equal to the slope m 1/4 times x minus this x coordinate 8. So distribute the 1/4. Y minus 2 equals 1/4 x minus 1/4 times 8 over 1 is 8 over 4, and 8 divided by 4 is 2. To finish the problem off, add 2 to this side. That means we're going to add 2 here, and those will cancel. So it looks like this problem answer is y equals 1/4 x. And that's it for section 2.1, day 1. On your assignment sheet, page 181, I did make this change last year. I can't remember if I updated it on your paper for this year. Make sure that these problems are crossed out, 3, 29, 33, 37. And I'll double check to make sure I did update your assignment sheet from the start of the school year.